So I'm going to talk about our mapping project, which covers these 3 dark mantle deposits on the moon. So for those of you who don't know, these dark mantle deposits are composed of volcanic glasses that were produced in explosive eruption. And we know this because we have samples that were brought back from the Apollo 17 landing site, which was in a dark mantle deposits. And so we can see that these are iron-rich glasses and crystallized beads. So for my PhD thesis, I used Clementine multispectral data to study several of the larger dark mantle deposits on the moon. And more recently, I used the Moon Mineralogy Mapper, or MCube, hyperspectral data to look at the Sinus Aestuum dark mantle deposit, because this is the only one that has spinel within it. So when I tried to map out where the spinels were found, I noticed some were in the highlands and some were in the Mare, and I was surprised at the Mare ones. And this was using these previous geologic maps, but it was when I looked at the higher resolution images that I saw that these smaller outcrops of spinel in the Mare were actually on these highland kapukas, or small islands of highlands. And then I also realized using these newer data sets that these pyroclastic deposits extended further than what the previous maps had shown. So from these observations was born the idea to do this new USGS map of these 3 dark mantle deposits. So we're mapping at 1 to 1 million scale and covering Sinus Aestuum, Rima Bode, and Mare Vaporum dark mantle deposits. So our goal is to better refine the extent of the deposits, to map and determine the composition of the Mare and highlands, do crater counting to get the ages, explore the geologic setting and history of the mapping region, and then look for and measure dimensions of plausible source vents that could have erupted the deposits, characterize the eruptions that emplaced them, and in general trying to understand more about the thermal and volcanic history of the moon. So we're currently on year 2 of a 4-year LDAP project. And if you go to the next slide. So this shows our current line work. We're not done yet, so we're still in discussion, but you can see what we've got right now for the geologic contacts, the structural linear features, and some surface features. We're mapping on the WAC base map, which is 100 meters per pixel scale, and supplementing with multiple other data sets. And we're digital mapping at 1 to 250,000 scale for this 1 to 1 million publication scale. And if you go to the next slide. So at the top is the mapping that was done by Willems and Macaulay in 1971, which was more recently incorporated into this unified geologic map. And at the bottom, it shows our line work, which I've superimposed on this multispectral imager with these various different ratios. And so you can see in purple and violet the dark mantle deposits stand out quite well. So what we just did, we recently had a meeting between all of us on Zoom and discussed some of the differences that we see between our line work and the previous maps that have been done. And we currently have several different units that are shown on the right there, but I'm sure we're going to be adding some more. And if you go to the next slide, this just shows you what Dan Berman's been doing, measuring the craters. And eventually, once we define our geologic units, we'll go ahead and establish ages using these crater counts. And if you go to the last slide, so this just shows our future work, where we're going to hopefully finalize the geologic map with the contacts, the units, the linear features, and then do the crater counting, produce polygons, colorize the geologic units, put together the DOMU and COMU, write up the text, and then our science component is then to try and look at plausible source vents and model the eruptions that emplace the dark mantle deposits, and then hopefully submit in year 4. Thank you.